Dear participants of conference, I would like to present the report, which title is Experimental Investigation of Reinforced Concrete Frame with Sway Columns under Cone Column Removal Scenario. Author Sergey Savin, Natalia Fedorova, Pavel Korenkov. Speaker Sergey Savin. Also, the phenomenon of progressive collapse is not realized so often in economically developed countries. In consequence, its consequence can be catastrophic. As for example, during the collapse of the Federal Alfred Murray Building in Oklahoma City in the USA in 1995, when the shutdown of one of the columns of the building as a result of the explosion led to the collapse of significant part of the building and dozens of casualties. Analysis of the graphs of changing strains over time obtained in the studies of Sesani and Sergey, which removing the cone column of the reinforced concrete frame of the building under demolition, it showed that after 0.069 second from the moment of accidental impact on the opposite faces of neighboring column of the extreme row, the deformation exceeds 1.875 and 1.363 times the values recorded after the damping of oscillation in the building system. This allows us to draw out two important conclusions from the point of view of assessing the nature of redistribution of the force flows in carrier system after the initial local failure. Sudden failure of the bearing element of the system, so-called initial local destruction, leads to the occurrence of dynamic effects in the structural system. Second one, during the structural redistribution of the carrier system, due to the failure of one of its elements, there is a qualitative change in strength-strain state of the elements. In particular, in addition to loading by axial force, there is increase in eccentricities of this axial load. The purpose of the present study was to substantiate experimentally and theoretically the parameters of impact on the reinforced concrete frame of the building at the event of a sudden removal of one of the load-bearing elements of the structural system, as well as to analyze the mechanism of destruction of the considered frame associated with stability failure mechanism, and substantiate the criteria for assessing such failure mechanism. For the purpose of the study, a two-story reinforced concrete frame was designed and manufactured. The design of this frame was selected based on the data of preliminary numerical simulation. The composition of concrete mixture for the manufacture of the frame was selected from the condition of obtaining concrete of B25 class by compression. Reinforcement of the frame elements was carried out with spatial frames with a symmetrical arrangement of longitudinal reinforcement. The fabricated reinforced concrete frame structure was installed on test stand. The condition for fixing the column on the first floor of the experimental reinforced concrete frame on the stand were fixed hinges, while the possible displacements of the frame from its plane were limited by means of bilateral linear ties in the upper nodes of the frame, which allow free deformation of the frame in its plane. Testing of the physical model of the reinforced concrete frame is carried out in two stages. At the first stage, a gravitational load was applied stepwise by 10 steps applied in the nodes of experimental model of structural system. At the second stage, a special device was used to simulate the instantaneous removal of the corner column on the first floor of the scale model of reinforced concrete frame. 0.133 seconds after the triggering of the device simulating the instantaneous removal of the corner column, the contact between this device and the joint of the experimental frame was kissed. After that, in the time interval between 0.133 and 0.167 second, a change in the direction of displacement of considered frame joint was observed. Started from the time 0.83 second, there was an intensive increase in displacement of considered frame joint, which at 1.167 second after the start of the accidental impact was accompanied by destruction of the central column at the second floor of the experimental frame. Based on the result of video recording of the deformation of the reinforced concrete frame, a graph of the vertical displacement of the beams junction above the device simulating and instantly remove it from the structural system was plotted. To estimate the reaction distribution time of the removed corner column, numerical simulation was performed using finite element bar model, which included the design of the experimental frame and the leverage load system. According to the result of the numerical simulation, a pattern of deformation of the reinforced concrete frame, similar to experimental one, was obtained for the following accepted parameters of the impact and the stiffness of the structure's elements. Coefficients 0.6 and 0.3 were accepted for the stiffness of structural elements. This takes into account the nonlinear nature of the deformation of column and girders, respectively. The time of the redistribution of reaction of removed corner column was accepted 0.1 second. This is practically 0.1 of the period of natural oscillation of the frame, according to the lowest mode corresponding to the experimentally established deformed state of the frame in the first half wave of the oscillation. The nonlinear dynamic and quasi-static analysis using the finite elements bar model in deterministic formulation made it possible to reveal a fracture form similar to the experiment when perturbation from the frame plane is specified in the form of the node displacement in the middle of the column by 0.184 of the height of the column cross section. As a criterion for evaluating of this failure was accepted increment stiffness. Conclusions. In the present study, an experimental and theoretical substantiation of the parameters of impact on the reinforced concrete frame of building in the event of a sudden removal of the load-bearing element of structural system, as well as an analysis of the mechanism of destruction of considered frame associated with buckling or stability failing mechanism, and the substitution of the criteria for assessing the one set of such destruction were carried out. Numerical and physical modeling of the emergency situation in the form of an instant removal of its conic loom from the reinforced concrete frame. It was found that the exhaustion of the bearing capacity of eccentrically compressed element of structural system can be caused by stability failure mechanism. As a criteria for evaluating of this mechanism can be accepted, it reaching the zero value of increment stiffness of this element. Thank you for your attention.